Hello, good morning, everyone. Thank you for joining us. It's my pleasure to introduce our colloquium speaker today, Professor Avi Loeb. Professor Loeb is the Frank B. Baird Jr. Professor of Science here at Harvard University and the director of the Institute for Theory and Computation, where he currently leads the Galileo Project. He grew up on a farm in Israel and went on to earn his PhD in physics from the Hebrew University of Jerusalem before working at the Institute for Advanced Study at Princeton. Over the course of his career, he has worked on a broad range of topics, from black holes and the first stars, to the search for extraterrestrial life and the future of the universe. And he has been an author on more than 1,000 scientific papers. Many of you also know him as a best-selling author of 9 books and from his prominent public appearances. And it is also his birthday today, so make sure you wish him happy birthday after the talk. Please join me in welcoming Professor Avi Loeb.
Thank you so much, Kelly. And I should say that yesterday I had a 90-minute interview with Natasha Zuvez from News Nation, and she asked me, you are very interested in whether there are extraterrestrials out there, and if you had the opportunity to meet them, but you might know that they're hostile, would you care about dying in that process? And I said, look, I'm not very attached to myself. I got my body from my parents, just like you get a car from a dealership. It's not that I'm proud of what my making is, so I would much rather know whether we have neighbors. That will have huge implications for the future of humanity than living a dull life filled with news reports on News Nation about the dismal way we handle our affairs here on Earth. And so I will start with my statement about science. I really believe, and people who know me would testify that's my approach, that we should have the humility to learn, and we should make mistakes in the process, because that's the only way to learn something new. You think you know everything, but you don't. However, in academia, where all of us are embedded, it's customary to be proud of your expertise. And I say that's not the reason we're doing science. It's the humility to learn rather than the arrogance of expertise. And I say that after 50 years. I basically, throughout my career, I went through half of the history of modern physics, half of that history. So I know what I'm talking about. And what I'll discuss today is on behalf of the Galileo Project that I'm very proud to be leading, that has about 50 researchers. Some of them are in the audience here. And we just this year, this academic year, we got 5 new postdocs in the ITC corridor. And let me start with some general statements about the art of doing science. So first, the most fundamental thing about science, why it's better than politics, is because it's supposed to be based on evidence. It's not a matter of convincing your peers that you are smart. That's not really the issue. The issue is whether you are describing the physical reality that we all live in. People have this tendency to believe stories, to go into narratives that give us pleasure as if we are important in the universe at large. I don't think so. We're not that important, and we are not at the top of the food chain. It's very likely that there is another civilization that is far more accomplished than we are in the Milky Way galaxy that existed for billions of years. Elon Musk is not the most accomplished space entrepreneur since the Big Bang, 13.8 billion years ago. So the first aspect of doing science is not coming up with a brilliant idea. We all know about string theories that work on this subject for 50 years. They haven't actually demonstrated that their ideas describe reality. They don't bring us into a testable prediction, and so that's not what physics is about. Physics is about chopping the head of wrong ideas with the guillotine of experiments. And so the first most important aspect of doing science is looking at the evidence. And if the evidence shows anomalies, we should be thrilled, because that's an opportunity to learn something new. We should not shove them under the carpet of traditional thinking the way that experts do. And so this is a beautiful illustration of scientific evidence. That's the image of taken by the Hubble Space Telescope of 3I Atlas. Over the past decade, we had the privilege of seeing the first objects from outside the solar system, near Earth. And this is the most recent visitor. By the way, the direction of the sun is where the elongation of the light around 3I Atlas, the glow around it, is pointing to. That's quite unusual, and we will talk about that. If you remove the spherical or the circularly symmetric glow around the nucleus of 3I Atlas, you are left with 3 jets, as we see here, symmetrically separated from each other by 120 degrees. That's not discussed, except for 2 papers that I wrote in collaboration with Tony Scarmato from Italy. And then there is this extension towards the sun, not away from the sun, as you see in comets, because usually dust and gas are being pushed away from the sun. Here we see a jet pointed at the sun that penetrates through the solar wind, through the solar radiation. And these features change over time, over a period of 7.1 hours. The jets are wobbling by 10, 20 degrees based on 30 images from the Hubble Space Telescope over the past couple of months. The second aspect that I find quite thrilling, and I should tell you this is a recent experience of the past year or so, is that artists are very inspired by this research, searching for other intelligent beings in the Milky Way galaxy. So an example is Greg Wyatt, who is named by many people as America's Rodin. He decided to make 2 sculptures, bronze sculptures of Galileo Galilei, and donate them to my office. What you're looking at is my office, which, by now is a mini museum. I removed all the file cabinets from the time that I was department chair, because I think the best is yet to come. I don't care about the past. And replaced them with 51 watercolors that Greg donated to my office, plus 2 bronze sculptures. He's now preparing the 3rd one. And the biggest gift that he gave me was a foundation to make my own sculpture. And I decided to call it The Alien, where I tried to imagine what an alien might be if it's a biological creature. I added another eye because I was always bothered. We can't see backwards. I don't know why. Evolution never led to a 3rd eye. And 3 legs, wings. Basically, this animal can go into any medium and survive there. I was just trying to think what would make our bodies better. And what you see in the middle image here is another huge painting or piece of art that I received just a few weeks ago from an artist in Florida called Peter Tooney. And it basically says, history awaits. Meaning, if we discover extraterrestrial intelligence, that would be the biggest event in human history. And by the way, I had a visit by a group of theologians here at Harvard, led by the current president of the Templeton Foundation, Tim Dalrymple. And they asked me, if we find extraterrestrials, how would it change our religious beliefs? And I said, I have 2 daughters. And when the second one was born, it didn't take away from the love that I have to the first one. So thinking that God is a parent that can attend only to one child is very limiting. They were happy with this answer. What you see on the left here is a book that I received just a few weeks ago from a teacher in Brazil, where the kids in the class decided, they were inspired by my writings. And by the way, the biggest reward that I get is I get many, many emails from parents who tell me, my child saw you on television, and as a result, she or he wants to become a scientist. There is nothing more pleasing than that, because I gave up on convincing senior members of the academic community to deviate from the beaten path. My hope is that the young scientists, the next generation, will do better. And there is a songwriter, a singer from the United Kingdom called Ollie Swan that wrote a song with the title Aliens Are Real. And his producer asked me for a statement, a blurb that they can accommodate the release of the song. So I said, yes, aliens are likely real. There are billions of Earth-Sun analogs in the Milky Way galaxy alone, and most of them formed billions of years before the sun. It would be arrogant of us to imagine that similar houses on the cosmic street hosted only microbes and had no intelligent residents. For 65 years, we've been searching for a phone call, waiting for a phone call in the form of a radio signal. Instead, we should search for a tennis ball in our backyard or a knock on our front door in the form of an interstellar object like 3I Atlas or some other unidentified anomalous phenomena. Fermi's question, where is everybody, is a question that every lonely person asks. Are we alone is the most romantic question in science. So let me play this song for you, just the very beginning, because we don't have a lot of time. That's it. You can listen to the full song when it comes out. And finally, I should mention the context of doing science. It's very important for us to engage in public outreach. And the reason is simple. The public funds science. The public is interested in the question of, are we alone? Not just in the search for microbes that the mainstream of the astronomy community is willing to invest $10 billion into in the next couple of decades, but actually, are there intelligent beings out there? And it's sort of a race between having our own artificial intelligence, which is in the form of computer systems that are built out of chips, not out of flesh and blood. This is also a sort of alien intelligence. We usually look at AI systems as if they are similar to us, but it's just like putting lipstick on a pig, trying to make the pig beautiful. AI systems are not us. At best, they can be digital mirrors. At any event, I think finding alien intelligence is far more impactful because all the AI systems that we develop are trained on data sets derived from this Earth. And if you meet an alien intelligence, it may be exposed to data sets that are far bigger, that we cannot imagine, that scriptwriters in Hollywood cannot really come up with. So going to science fiction movies is not really the way to figure out what our neighborhood is like. And so in terms of my public outreach, aside from some books and essays that I have a few million readers every month of those essays on medium.com, recently I started having social media presence. Until then I said, I don't care how many likes I have. I don't really want to impress anyone. But then what happened 3 months ago is that some people decided to make fake AI-generated videos of me, in my voice, in my image. And it got to such an extreme that a month ago, an 82-year-old woman came to my office at Harvard. She said, my name is Abby Rockefeller. happens to be the daughter of David Rockefeller. And she said, I had a very frustrating experience because I saw a video of you, and it was very convincing. I was so excited. I sent it to all my friends, and one of them told me that it's fake. So as soon as she left my office here, I said, that's it. I will create my own content. I have my own YouTube channel where I will present what I really think, and I will be able to basically destroy all the misinformation that people are injecting with fake videos. That's a real risk to science in the future. How would people know what to believe? Another aspect of public outreach, I was invited to a NASCAR car race back in October, where one of the racers put my image together with 3i Atlas on the hood of his car. And he let me get into the car. Then he wanted me to drive the car. My wife said, no way, you're not taking that risk. And by the way, I asked him, why is it that, nowadays there are self-driving cars, they can probably win against human-driven cars. And of course, it's the same question as to why do we still play chess, right? We want to see people playing the game. We don't care that technology can do better. And just last Friday, I had 18 interviews on television, different stations. And when they come to me, I agree because I think it's a good way of attracting the public to science. Apparently, it does work. This is just a title from a New York Times Magazine article that appeared a couple of years ago. So the standard statement is following what Carl Sagan emphasized, that extraordinary claims require extraordinary evidence. Well, I don't think it's an extraordinary claim to say that something like us existed billions of years ago around another star, because there are billions of Earth-Sun analogs with similar circumstances. And it would be arrogant of us to argue that we are unique and special. Especially if you read the news every day, there is clearly room for improvement, right? So I would argue it's an ordinary claim. Just think about string theory. There you're talking about extra dimensions. We've never seen those. They don't come with definite prediction. That's accepted within the mainstream of particle physics for 50 years. Whereas talking about things like us in environments that resemble the Earth, that's not speculation. That's common sense. Why should that be out of the mainstream of astronomy? Right now, if you look at the decadal survey, it's all about the highest priority, more than $10 billion to the Habitable World Observatory. What about hedging our bets? Clearly, microbes are probably more abundant than intelligent beings. However, to detect their signatures takes a lot of effort. These signatures are very subtle. You look for oxygen, methane in the atmospheres of exoplanets. Well, those gases can be also produced by natural geological processes, so it will never be conclusive. You're willing to put $10 billion into that and zero federal funding towards searching for technological relics. And when you look at comet experts, what they're saying is everything that comes close to Earth must be either an asteroid or a comet. And I just tell them, you behave just like AI systems, that depending on the training data set. So you were trained throughout your career on a data set that includes only icebergs or rocks. Now, we know that there are space objects that we produced hovering near Earth, within the Earth's orbit around the sun. We sent some towards Venus, towards Mars. So there are technological objects in the sky. So why don't you add that to your training data set? Why is that so complicated? So my point is, it's an ordinary claim to imagine something like us or better than us. And therefore, all we need is ordinary evidence. This subject should be within the mainstream of astronomy. This should get the same priority as searching for microbes. The way I think of it is you go on a blind date, in this case, of interstellar proportions. You can aim low or you can aim high. My advice is, when you go on a blind date, there are many more dating partners that would be rather mediocre. So you can say, I'm just going for the most common mediocre dating partner. I say, no, let's aspire to meet someone more intelligent than us, because then we can learn something from it. And the public cares a lot about this. The public really wants it. Nevertheless, academia says, no, 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 no. We just want microbes, that's it. That doesn't make sense. It's not common sense. Why are we doing that? Let's hedge our bets, invest billions of dollars in both searches. Why should that be controversial when it's common sense? And frankly, I seek a higher intelligence in interstellar space because I don't often find it here on Earth. So, as I said, microbes are abundant. We can search for them, but technological signatures might be easier to detect. Suppose we get a high-resolution image of an interstellar object and it has buttons on it. That's it. You don't need to build a $10 billion telescope to look at a distant star. You know that there is life, and not only life, but intelligence out there. That's simple. Now, Enrico Fermi, back in 1950, sat for lunch at Los Alamos and said, they were talking about extraterrestrials. He said, where is everybody? And if I was there, I would put my arm around him and say, Enrico, that's a question every lonely person asks, and don't be so presumptuous. You're not that attractive. They will not come to you. You need to do a search. That's what you tell lonely people. You say, you should engage in the search. You should go to dating sites. And Enrico didn't build a telescope. Now, it's quite remarkable because the answer could be rather simple. Where is everybody? Maybe it's right here. Have we checked? Not really. Only over the past decade we started discovering interstellar objects, and they are bigger than a football field. All the objects that our best telescopes can detect are bigger than 100 meters within the distance of the Earth-Sun separation. Could be, and 100 meters is roughly the size of the Starship rocket, the biggest rocket we ever constructed, which is mostly the fuel reservoir. So just think about it. We are not sensitive with our telescopes to the most common probes that we launch to space. We can't see a Voyager-like probe entering within the orbit of the Earth around the sun because it doesn't reflect enough sunlight. But the intelligence agencies have a day job. The defense budget for 2026 is $1 trillion. What is it for? In part, to monitor the sky, the oceans, for any national security threat. So they keep looking, and they're not focusing on distant sources of light like astronomers, so there is a chance that they would see something unusual. If there is something rare, they will be the first to notice it, not astronomers necessarily. And there were 3 reports delivered to the US Congress in recent years talking about objects that the US government cannot identify. And we should take them seriously. These are serious people talking about it. Most recently, just last week, former President Obama said, the truth is that when I came to office, I was like, all right, is there a lab somewhere where we are keeping the alien specimens and space tubes? That's what he said just a week ago. And when asked, are aliens real? He said, yes, but I haven't seen any. Former President Obama said that. And then he tried to backpedal because there was a huge amount of interest. And then, after that, current President Trump was asked about it. And he said Obama should not have said aliens are real, that's classified. And made the statement that based on the tremendous interest shown, I will be directing the Secretary of War and other relevant departments and agencies to begin the process of identifying and releasing government files related to alien and extraterrestrial life, unidentified aerial phenomena, and unidentified flying objects, and any and all other information connected to these highly complex but extremely interesting and important matters. God bless America. And so that's the rationale for the Galileo project. We can wait for the government to release their data, but it might be like waiting for Godot. May never arrive, or the data will be redacted, like the Epstein files. And so as scientists, we can figure it out. We can just look up. What's the problem? Why do we need to wait for Washington to tell us what lies outside the solar system? That makes no sense. So the Galileo project aims to build observatories that monitor the sky and look for technological artifacts that may have arrived from other civilizations. And we do it in the infrared, the visible, the radio bands, and audio band. And just this week, we created a website that allows members of the general public, volunteers, to look at our data, at our images, and classify objects. We're looking at millions of objects per year. We have 3 observatories, and we need to train our machine learning software on the ground truth, which we want to establish based on humans. So these are some images from the 3 Galileo observatories. One is in Massachusetts, not far from here. Another one in Pennsylvania. And the latest one in Nevada, Las Vegas. And this is the one that we visited in summer 2025 to install the Galileo Observatory. One unit of that observatory is on top of Sphere in Las Vegas. I don't know if any of you went to the U2 concert there, but it's an amazing place. They actually gave us a VIP tour. They showed us a film, just the 3 of us. Alex was there and Lily was there. This is me inside the Sphere. You can see me there. It's an amazing construction, about 100 meters in radius. And it has an exosphere, 17,000 LEDs displaying an image. Outside the sphere, there is also an inner sphere where 17,000 people can be accommodated. And here is a video. When we went up, all the way up, we had to be careful not to bump our head against all these pipes as we installed the observatory on top of the sphere. So that was an amazing experience. Started at 4 a.m. Very recently, I don't know if any of you saw this film, Marty Supreme. Timothée Chalamet went to the top of the sphere in order to create the promo for this film, because they lit up the sphere as a ping pong ball. The movie is about a ping pong player. And so they took images of Timothée Chalamet. You can see him right here. And here is a component of the Galileo Observatory. Here is another one. So in the promo to this movie, you can see the Galileo Observatory. And basically what you're seeing here, it looks like an R2-D2, but it has 8 infrared cameras looking at the entire sky at all times. And there is also a visible light set of cameras. And this week we started, we went through a major, how should I say, phase transition, where we're able to figure out the distances to objects in the sky because we're looking at them from different directions, with different units, just like we have in our head 2 eyes looking at an object in order to assess the distance. So the same thing can be done in this observatory that has 3 units separated by about 10 kilometers. And here are 2 images from the 2 observatories. And you can see an object here. These are birds. By the way, this is in the infrared. Here is the same object from the other observatory separated by 10 kilometers. And it's the same object, so we can tell how far it is. And the precision by which we can tell that is better than 10% at the moment. We are planning to improve it down to 1% distance estimates. And of course, that will have important implications, figuring out the speed of objects, the velocity, as well as the acceleration. So if we see objects that are outside the performance envelope of human-made technologies by a large margin, we would know that this technology was not made by humans. Now, I would like to shift gears to a different frontier, which just took place over the past decade, and that's interstellar objects. So for the first time, the astronomy community noticed, within the orbit of the Earth around the sun, there are objects that arrive from outside the solar system. We can tell that based on their speed being in excess of the escape speed, which for the orbit of the Earth around the sun is square root of 2 bigger than the Earth's speed around the sun. So the Earth speed is 30 kilometers per second, escape speed at 1 astronomical unit is 42 kilometers per second. Anything flying or moving near Earth faster than 42 kilometers per second came from interstellar space. So turns out there was one such object back in 2014 in a catalog compiled by NASA that we discovered, and that was a meteor. It basically was half a meter in size, collided with Earth, and created a fireball as a result of its friction on air. So small objects can be detected that way because they create a fireball. In this case, 1% of the Hiroshima atomic bomb energy was released. And so US government satellites detected it. They're monitoring the Earth for the heat produced by the engines of ballistic missiles. And we all know that lots of the ballistic missiles launched by Iran were immediately recognized. How? Well, because the Earth is being monitored by a set of satellites. But every now and then they see an explosion that has nothing to do with humans. It has to do with an object impacting the Earth. And most of those are rocks from the asteroid belt within the solar system. However, every now and then we see something moving too fast to be bound to the sun. This is the first recognized example. And the second was Oumuamua that was discovered by the Pan-STARRS survey telescope in Hawaii back in 2017. It was given this name because it means in the Hawaiian language, a scout. And it was roughly the size of a football field. And then Gennady Borisov, an amateur astronomer, discovered a comet that was clearly a comet about 400 meters in radius in 2019. And then 3I Atlas was discovered on July 1st, 2025, by the Atlas telescope that was monitoring the sky as part of the Earth, the planetary defense of Earth. We want to find if there are any rocks the size of a football field that are about to hit the Earth because we are smarter than the dinosaurs, And just about a week and a half ago, together in collaboration with my Galileo postdoc, Richard Cloet, we discovered an interstellar meteor from 2022 in the same catalog that NASA compiles. I should say that this discovery took only 10 minutes because we used an AI agent. The first discovery took a week because I used an undergraduate student. So the AI systems are quite amazing in doing tasks of this nature. So you can ask, okay, where did these objects come from? Turns out that Oumuamua was actually confined to the thin disk of the Milky Way galaxy because in the local standard of rest, it was barely moving. So if you go back in time, and that's what we did with my undergraduate student, Shokruz Kakarov, you go back in time, integrate the trajectory in the potential of the Milky Way galaxy, what you find is that the scale height of this orbit is, very small. It's of order 10% or less than 10% of the scale height of the disk, of the thick disk. So we're talking about a tiny, like 100 tenths of parsecs or so. So if it's natural, it should have arisen from a relatively young star, because that's where the cold gas is. And then 3I Atlas, on the other hand, was moving at about 60 kilometers per second relative to the sun outside the solar system. So it originated from the thick disk. Its orbit spans a scale height of 400 parsecs or so. And Borisov is in between. So these are some images that were obtained. We obtained a lot of data from primarily space telescopes. The highest quality data was obtained from the Hubble Space Telescope in terms of imaging, and then in terms of spectroscopy from the Webb telescope, and then also from the Keck telescope. But SphereX gave us the large-scale view of all the chemicals that one can find around the nucleus. But the most striking feature of 3I Atlas is that it came within 5 degrees in the plane of the planets around the sun. So you see here all the planets: Earth, Venus, Mercury, the sun, Jupiter, and Mars here. And they are roughly at the same plane to within a few degrees, all of these, because they form from the same disk, protoplanetary disk. And here comes 3I Atlas, the third object that was found by astronomers, and it's in this plane, moving at 60 kilometers per second, not 43, just above the scale, but actually very high speed. How did it know that it needs, why does it come in this plane? Now, the survey in principle was sensitive to all directions, and actually Oumuamua came at a large angle, for example. It was much smaller. 3I Atlas is very bright. It's a big object, 2.6 kilometers in radius based on the latest data from Hubble. So there must have been a lot of objects like 3I Atlas, if it's natural, that we missed even before Oumuamua, because that's a bright object that is easy to detect. The Atlas telescope is a small telescope, 0.5 meter, So we use big telescopes. We miss those. Why? Because we are not really thinking about interstellar objects. We are not monitoring them. We are not focused on finding them. That's why. And so after 3I Atlas came closest to the sun, there were beautiful images from amateur astronomers that showed the jets coming from the nucleus. But when we analyzed the image from the Hubble Space, the images, we had about 30 images from the Hubble Space Telescope, they show a system of 3 jets that are symmetrically separated from each other by 120 degrees. And the question is, are we looking at thrusters that are technologically produced? Why is there this symmetry? Or is it just a random orientation of pockets of ice on the surface of a rock? Just asking this question is heresy. It's banned. If I put this question in a paper, my paper will never get never get published. I'm saying that based on experience, because an editor asked me to remove a sentence related to this possibility, or my paper will never be published. Remove a sentence. And when I left the sentence on an archive version of my paper, the chief editor of that prestigious journal said, you should not list this paper as published in our journal unless you remove this sentence and put the actual version that was published. Just think about it. We are not even allowed to discuss it publicly, the possibility of something like that, when we are speculating like crazy about the nature of dark matter. We haven't found dark matter. $10 billion into the Large Hadron Collider didn't help us find dark matter. And lots of ideas, including weakly interacting massive particles, were ruled out after investing $10 billion. That is considered part of the mainstream. Hundreds of papers on WIMPs, on other things. Everyone celebrated, people were getting awards, everything is good. Mentioning the possibility of a technological origin for an interstellar object, forget about it. Now, there are actually, I listed 18 anomalies of 3I Atlas, aside from the fact that its trajectory is in the plane of the planets. I'll just very briefly, because we don't have a lot of time, you can find them on my essays on Medium. The rotation axis of 3I Atlas is pointing at the sun. There is this anti-tail that I mentioned. The gas plume around 3I Atlas contains much more nickel than iron. And we don't see that in astrophysics because nickel and iron are produced by supernovae. And you always find nickel and iron. But in this case, just nickel. And then the authors of the paper said, oh, well, maybe the carbonyl chemical pathway that we use in our industries to make nickel alloys for aerospace applications, maybe the same process operates in nature. So that was published to say that nature can mimic our industries. That is okay without saying that technology is required for that. And actually, the nucleus of 3I Atlas, is tens of thousands of times more massive than Oumuamua. Why are we seeing the third object so much more massive? Could it be that it visits the solar system with a purpose? And there were organic molecules detected from it, around it. The question is, why did they appear only after it passed close to the sun? I mean, for example, methane is much more volatile than carbon dioxide, and carbon dioxide was found early. Methane was found only late. And then methane is less volatile than carbon monoxide, which was also found early. So somehow methane arrived late, and it's obviously a biosignature. So these questions are not being asked and are suppressed by referees and editors, not allowed to speak about them. If you put it in a paper, the paper will never get published. And then there is this wobble of the symmetric arrangement of the three jets. Now, early on, back in July, my point was simple. I said, the intelligence agencies are very much aware of situations. After September 11th, after October 7th, there are circumstances that you can't really forecast. You say very low probability that someone will, fly a plane into the World Trade Center. Forget about it. But then it happens. Okay, so what's the best way to prevent that from happening again? It's to pay attention to low probability events that have huge implications for society. That's very reasonable. Reasonable people do that. Attend to low probability events because they have high implications for society. So, even if we think that 3I Atlas is definitely a comet of natural origin, but it shows some anomalies, we must attend to it. And I defined a classification scale where 0 means a natural object of no threat to humanity because the object is not coming close to Earth. And 10 means red alert. This object could be alien technology and could be a potential threat to Earth. So, as a person in academia, I thought nobody would pay attention. But then someone filed a Freedom of Information Act request to the CIA and asked them, please release any records that discuss 3I Atlas, if you have them. And the answer from the CIA was, we can neither deny nor confirm the existence of records on 3I Atlas. If they had no records, they could say we have no records. Now, this is not limited to the United States government. By the way, this is the first astronomical object that is probably discussed in the CIA. I don't know of any supernova that was ever discussed at the CIA. On December 19th, 2025, there is usually a summary of the year event where Vladimir Putin answers questions from journalists. So Amazingly, one reporter that you see on the right here asked him about 3I Atlas. What did she ask? She said, I have a question about the unusual object 3I Atlas, which is currently approaching us. If the predictions are to be believed today, and by the way, this was exactly the date when 3I Atlas came closest to Earth, December 19th, either a spacecraft with an engine or just a comet will approach Earth. My question on this is, what do intelligence services report to you? She asks Putin. And he gave an answer, detailed answer, basically reflecting what astronomers are saying. This is a natural comet, nothing to worry about. But you are naive if you think that this kind of a question is just spontaneous. It must have been orchestrated. And it shows that people in government in various nations were discussing 3I Atlas. Because it could be a black swan event, as I was arguing. And I'm also grateful to Representative Anna Paulina Luna that urged NASA to use the Juno mission after I wrote a paper saying that, in principle, if the Juno spacecraft around Jupiter uses its fuel, it could intercept the path of 3I Atlas. It could crash into it. It could take a high-resolution image. That's great. And so Representative Luna echoed that sentiment and asked the NASA administrator back then, Sean Duffy, to pay attention to that. Unfortunately, there is not enough fuel for Juno to maneuver and meet 3I Atlas, but there is a radio antenna on it that could, for example, observe it. 3I Atlas is the third object identified by astronomers. The first one was Oumuamua, and its brightness, as a result of reflecting sunlight, changed by a factor of 10 as it was tumbling every 8 hours. Just think about it. Look at a piece of paper tumbling in the wind, and what you want is the surface area to change by a factor of 10 projected on your field of view. That means the object has an extreme shape. And there was a detailed analysis implying that it must be flat. So that's a very unusual feature. A flat object, most likely like a disk. And there was also an excess push that the object exhibited, an acceleration, non-gravitational acceleration away from the sun, roughly declining inversely with distance squared, without any evidence for dust or gas around it, the way you see in comets. The Spitzer Space Telescope looked very deeply around it, couldn't find any trace of carbon-based molecules. So what's going on? What is pushing it? And I said, maybe it's just the sunlight pushing it, because that's what you expect. A decline is 1 over distance squared. Again, that's heresy. You're not supposed to say that. Gladly, when I submitted the paper, there was not this culture of zealots attacking me did not exist yet. So the editor sent it to a referee, and the referee said, that's a great suggestion. The paper should be published. In fact, we know that it's flat. So the paper was accepted for publication within 3 days. And then once it got attention from the public, all the attacks started, which is to state once again that the strongest force in academia is jealousy. So the fundamental question is whether 3I Atlas is a rock of some unusual shape that is, for some reason, being pushed away from the sun. So it's a dark comet, maybe, without any visible gas or dust around it, or some a light sail or a broken piece of some technological object. Turns out that in September 17th, 2020, that was 3 years after Oumuamua was discovered, the same telescope in Hawaii, Pan-STARRS, discovered an object that is pushed away from the sun by reflecting sunlight. And it took them a few months to take a spectrum, and they realized, oh, this one is made of stainless steel based on the spectrum. So then they realized, oh, well, this one is actually the upper stage of a lunar lander mission that we launched in 1966. So it's definitely technological because we produced it. The question is, who produced Oumuamua? You have a proof of principle that sunlight can push objects if they're thin enough. Then on January 2nd, 2025, the Minor Planet Center in this building cataloged a near-Earth object as an asteroid in this building. And then within a day, they realized, oh, this one is actually moving along the path of the Tesla Roadster car that was launched by SpaceX in 2018 as a dummy payload on the Falcon Heavy. So then they said, sorry, we take it out of the catalog. It's not a rock, it's a car. So my question is, we know about this car because we launched it. What about an interstellar car? They would insist that it's a rock of a type that we've never seen before. And that's exactly the response that you will get from a cave dweller that finds a cell phone. It's a rock of a type that I've never seen before. The Voyager spacecraft will cross the Milky Way galaxy in less than 1 billion years. We did the integration with my student. So our own probe will be able to be on the other side of the Milky Way disk relative to the sun in less than 1 billion years. Most stars, if you look at the star formation history of the Milky Way galaxy, most stars from billions of years before the sun, there was plenty of time for the 1970s technologies. I'm not talking about future technologies. I'm just saying technologies from the 1970s could bridge the gap between stars in the Milky Way galaxy on a time scale that is much less than the time difference between the birth of most stars and the sun. The sun formed in the last 1/3 of cosmic history. 4.6 billion years ago is exactly 1/3 of 13.8 billion years, the age of the universe. Exactly 1/3. So we are latecomers. And so pretending that packages could not be found in our backyard is inappropriate. And suppose you find a tennis ball in your backyard and you know that you have a neighbor. Will you hide it from your family members at the dinner table? No. So, because the same neighbor may knock on the front door, the same neighbor might affect the life of your family member. So my request to government is if they have data that is truly anomalous, they should share it with scientists like myself. For the same reason that it didn't make sense for the Vatican to put Galileo in house arrest so the public would not know about what he's arguing. They admitted in 1992 that he was right. That was 350 years after he died. Not a good public relations stunt. You cannot hide some fact about our cosmic neighborhood. You can delay the dissemination of information. But if government has some useful information in this context, I would love to help them figure it out. And if they want me to sign a non-disclosure agreement, I'll do it. I just want to know the answer. Think of me as a kid. I don't care, whether other people know it, whether I'm being liked. This is irrelevant. I just want to know it. So this is the data on the new interstellar meteor from a couple of weeks ago that we analyzed, and it basically exploded 600 kilometers from Peru. So we might go there. And I actually went to the Pacific Ocean in 2023, leading an expedition that was searching for the materials of the first recognized interstellar meteor. The question was, in my mind at least, is it a Voyager-like meteor or just a natural rock? And there will be a Netflix documentary about this expedition and the entire work done by the Galileo Project coming out in 2026. So I highly recommend that you check it out. So this meteor had 3 flares, and it exploded in the lower atmosphere. So it must have been it had a very high material strength because it survived down to 20 kilometers above the Pacific Ocean. This is the team that went there on the deck of the ship that was fittingly called Silver Star. And what we did is construct a sled. You can see it here in the middle image that has magnets on both sides. The ocean depth was 2 kilometers at that location. That's just under where the fireball was localized by the fireball. The light from the fireball was recognized by the US government satellites, and that's how we knew where it is. And so what we did is place that sled on the ocean floor, and we went back and forth 26 times across a region of about 10 kilometers, looking for any debris left over from the meteor. And we collected some materials. This is on a rainy night. We brought the sled every 8 hours to the deck, and most of the time it was at night. And I didn't get much sleep, but it was worth it because at the end we brought a sample of material in this briefcase that I FedExed to my home, and brought it to the laboratory of Stein Jacobson, a world-renowned geochemist at the Earth and Planetary Science Department. You can see him here standing next to me, much taller than I am. And on the other side is Sophie Bergstrom, a summer intern that was here at the time, and she helped us find most of the spherules. These are molten droplets from meteoritic material. About 850 of them were found, mainly thanks to Sophie. And then we studied them. You can see here one of those. It's very distinct relative to the background sand particles. And we analyzed them, and what we found is that 10% of them have a composition that is very different from solar system materials. And so here we show the abundance relative to the solar system abundance. One is equal to the solar system abundance as a function of the element. And what we found is some elements like beryllium, lanthanum, uranium are up to 1,000 times more abundant than you find in solar system materials. So that's a possible indication that we found some material from outside the solar system. Right now, we're engaged in studying the isotopes because those are very difficult to change. And we have some exciting results that I cannot show as of now because we're still in the process of writing the paper. But of course, that doesn't tell us whether it's a natural object or maybe of artificial origin. For that, we need bigger pieces. And one possible natural process is the disruption of a planet by a dwarf star. So imagine a planet that is driven gravitationally to come very close to a dwarf star, a rocky planet. For example, as a result of the Kozai-Lidov effect. And then it gets to the point where it can be tidally disrupted because the mean density of the sun is roughly solid density, 1 gram per cubic centimeter. That's the sun. You cannot destroy a planet when it even grazes the sun because the sun's density is comparable or smaller than the density of the planet. But a dwarf star has a density much larger than solid. For example, a dwarf star with 1/10 of the mass of the sun has 1/10 of the radius of the sun. So it's 100 times denser than the sun, 100 grams per cubic centimeter. So when you bring a rocky planet next to a dwarf star, it will get disrupted tidally. And in the process, you'll get a stream of rocky material that gets melted, and perhaps that will generate interstellar objects that are of natural origin. So that's a paper that we wrote with Morgan McLeod. And the next expedition that we hope to make, it was an expensive expedition, $1.5 million in cost. The next one will be even more expensive because we'll go for bigger pieces that we could find if we use a robot. But the next year is promising to be very exciting thanks to data from the Rubin Observatory in Chile, where we expect to find over the next decade, dozens of interstellar objects. The detection rate could increase by 2 orders of magnitude because this observatory is using a camera with 3.2 gigapixels, 1,000 times more than the number of pixels on your cell phone. And it monitors the southern sky every 4 days. So the hope is we will find many more objects like Oumuamua, Borisov, or 3I Atlas. And once, I think it's a mistake to go on a date and marry the first person you meet because you don't have a sample. And for the same reason, you want to find a lot of interstellar objects before you can decide which one is really anomalous. So at the moment, we just have 3 plus the interstellar meteors, but within a few years from now, we might have many dozens of them. So that will improve our understanding of their origin and which one is really anomalous. And the way I see the future is that we want to cover not only the southern sky, where the Rubin Observatory is monitoring, but also the northern sky. Why should we miss half of the objects? And for that, we can use the Argus array that is being planned. And then we want to have a lunar optical interferometer that is with a baseline more than 100 meters. So it's effectively like a telescope more than 100 meters. And it could resolve an object like 3I Atlas at a distance of 1 astronomical unit. And that would allow us, if we get a high-resolution image, to immediately decide about the nature of this object. And finally, we want interception missions that will take close-up photographs of the objects or land on the objects. Just think about a new frontier of astrobiology where you land on an interstellar rock and scoop some material, bring it back to Earth, and then you can examine whether the material that came from another star that took billions of years to arrive to our backyard, whether that material has any of the building blocks of life as we know it. It's a completely different way to do astrobiology. Not looking at materials from the solar system, but from another star. For us to go to another star and bring the material back with our rockets would take billions of years. Or at the very least, millions of years for the nearby population of stars. And altogether, either by monitoring the objects in the Earth's atmosphere through the Galileo Project Observatories, or finding new interstellar objects with the Rubin Observatory, or actually having this concept that we came up with, O.M. Trivedi, a student, my hope is that we will have data that could inform us as to whether there are visits by technological artifacts to the solar system. And that's the way science should progress, based on data and not prejudice. Thank you.
All right, we have time probably for 1 or 2 quick questions. So this hand first.
Thank you. I was struck by your comment on dwarf stars, tidally disrupting. What we do see is quite a number of white dwarf stars.
Yes.
Which are they're getting all your technological elements are coming in, and they're being something left from the original planetary system.
That's right. And in fact, our own colleague Vandenberg found some of the early evidence for that. Indeed, on the surface of a white dwarf, we can easily notice if materials are deposited as a result of debris surrounding the white dwarf. But my point is that this should also happen much more abundantly near dwarf stars, which are the most common type of stars. So we don't have evidence because if something sinks into a dwarf star, it gets swallowed by the dwarf star. On the other hand, in the case of a white dwarf, it lands on the surface and you can see those heavy elements for a while spectroscopically. So my point is the most abundant type of stars must be disrupting rocky planets. We just weren't aware of that. I mean, every now and then you might see a flare that you can associate with this process, and some people have claimed. But it could also generate a population of interstellar objects that are very unique because you melt the rock in this process. You create a stream of molten rock. And then this molten rock breaks into pieces that fly out. And guess what? What is the speed that you end up with? 60 kilometers per second, which is the speed that was measured for the interstellar meteor outside the solar system. It's the speed of 3I Atlas. And, even this suggestion did not get much attention from the scientific community, even though to me it sounds very plausible. What the scientific community focused on is 3I Atlas has 60 kilometers per second, therefore it must have originated from an old star that is older than the sun, that populates the thick disk. And I say, no, that's not true. That's not a true conclusion. They went to the press and said, that's a definite, robust conclusion from the mainstream of astronomy. And I said, because this is not robust because you're ignoring the possibility that this high speed was inherited in the process that produced the interstellar. So in the case of a brown dwarf, a dwarf star, you get a speed of 60 kilometers per second because of the nature of the tidal disruption process, because you're approaching the star very close, at the tidal distance where the speed is hundreds of kilometers per second. And so as a result, the fragments that will come out will move at 60 kilometers. Has nothing to do with the age of the star. And so, yeah.
Thanks, Avi. There's this really cool mission called Comet Interceptor that I'm sure you know about.
Yes, European.
Right, the
But,
Europeans. And so my question is, I know that they're unlikely to, so for those who don't know, it's this crazy idea where they're going to launch something into space in like 2028, 2029, and then they're going to sit there and decide which comet looks the most interesting and then send it just to that one. And so, of course, I know you would have interesting choices, but do you think that these things are going fast, right? And there's not that many of them. Could
Exactly.
it even go there, or would you need a mission
No,
that was
so the problem
special?
is this is a mission that was imagined by the European Space Agency, and they provided it with the capability of a velocity shift of 2 kilometers per second. That's it. So the problem is these objects, interstellar objects, are moving at much higher speeds. And right now, I think you need a mission that moves at 10 kilometers per second or so in order to catch up. It all depends on how early you identify the interstellar object, because if you see it very far away, you have plenty of time. So it's not just a matter of the velocity shift that you give the interceptor. You need to bridge the gap between the location of the interceptor and the path of the object over the time that you have between the alert and the closest approach. So that means that if you detect it very early, let's say 6 months to a year, you can use a mission like the interceptor perhaps to bridge the gap. But it's much better to have thrusters that can give a boost of 10 kilometers per second thrust. I think this mission was designed in the context of the solar system, but we should be far more ambitious. I think we should recognize that now that we have interstellar objects, it's a completely new frontier in astrophysics that could educate us about things differently than we are used to, because we are used to looking remotely, using a big telescope looking far away. Now you have visitors that bring materials from far away. We've seen dust, but here we're talking about big objects. And those can actually teach us something completely new about the environments where they come from. Exactly. So it's a new frontier in astronomy. Was mentioned very briefly in the decadal survey, but I think it deserves a much bigger place. And also we should fund interceptors or an interferometer on the moon as part of the Artemis program to image those objects. I think we should invest in the study of interstellar material because it may be the next big discovery that comes from there.
All right, we need to release the room now, but please ask your questions to Avi after the talk. And everyone, let's thank Avi again.